Yeah, I don't know if it's just you speaking quietly. Yeah. Oh. Okay.
Hello, everyone. Can we hear? Is that I turned it down on purpose. Hello. We hear okay, so we hear both of
Oh, I
us,
love
right?
your whiteboard.
Okay. Hello, guys. Thanks for coming to my stream about math. Today we're gonna
Oh
talk about.
boy.
I'm still pretty quiet. Okay, hold on. Mickey could be a little louder.
Am I okay?
They're as good.
Okay.
Okay. Turning it up and up and
You
up
can always
and up and up.
you can always lower my volume in Discord if you need to.
Okay. Sound like you're in a construction zone, Mickey. Well, that's because I am.
That's weird. You don't sound like that to me, so I don't know what's going on.
Is my volume okay now, guys? Or should I turn it up more? Something sounds funky. I don't know what it is. You did not get louder.
Bonky.
Okay.
How did you not get louder?
uh, am I getting louder now? Is this happening more? Yell into my. um, I'm wondering if I should just change my mic. Because last time I streamed it didn't see, yeah. Okay. Alright, hold on. Hold on. Technical difficulties as usual. It's the V-Haunt way.
Yeah.
Okay. Oh, wait. Does this work? Is this better?
How is there... Does
No,
this
not
work?
better. Okay, hold on. One moment.
I don't understand. How are they hearing construction things? I don't hear anything.
What about
Maybe it's
that?
Discord's like
Okay.
auto compressor or something.
What about that? How do we feel now? I believe I have switched my mic. Nothing changed, Mickey.
How
Okay.
did nothing change?
Nothing changed, Mickey. Nothing changed. Well, banging and stuff. I don't know that that's for me. Is it for Fiyera?
Is it from me? I don't think there's...
I mean, there's
Oh,
definitely
maybe it is. Let
banging
me...
here,
Okay, hold
but
on.
mute Fiyera on Discord. Okay, she's muted now. It was Fiyera.
I don't know how to change that.
Oh, okay.
It's me?
How about this? Is that better? Can you hear me now?
I changed it. Is this better?
Let me turn down Fiyera. Hold on.
I made it. I turned on the. Okay. There's
No,
literally. I don't think
I am
there's
so
construction going.
sorry. I'm trying to do a million things at once. I
What
am at
level
4.6.
are you at? 4.6?
Okay. Okay. My goodness, Veronica is like scolding me here. Okay. Okay. I'm turned up. I'm turnt, as the
Oh
youth
boy.
would say. That's what, yeah, I guess so. Yeah. That is what happens when I don't listen to her. How do you know what turnt is? Well, I found this
I
website
taught him.
called Urban Dictionary, and I've been looking at
Oh
that a
boy.
lot. Slightly better, much better. Okay. Is it slightly or much? What was that? I just heard something go boop boop. I don't know what that means.
Did something disconnect?
Oh, maybe something did connect. Who to trust? It sounds good to me. Okay. Aha. Okay, that's weird because she shouldn't be. Hold on.
Turn me down.
Doing, 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 doing. Now what?
Now what?
Is that better? Is Fiyera
That better?
in appropriate volume? That's better. Okay, now we're into it. Now we're doing it, folks. Okay. Alright. Whoopee. Okay, well, welcome. Yes. So, welcome to my kitchen. Welcome to my stream.
I'm pretty sure this is not a kitchen.
It is not a kitchen. We're in a classroom. My classroom, Professor Mickey Sparkle. And today we're going to learn about irrational numbers. Fiyera,
Oh.
do you know what an irrational number is?
I used to.
You used to, okay. Alright, can you take a guess? Based on what it sounds like?
I have no. I honestly don't remember.
Okay, so an irrational number is a number that cannot be represented as a ratio, meaning you can't write it as a fraction in any way. Yes, this number...
How are you writing?
How am I writing?
Yeah, that's so cool.
Oh, well, I have my ways.
Okay.
Thank you. Ratioed. Now, what does that mean?
We don't need to get into it. It doesn't have to do with math.
Okay. Yes, Dawn helped me. Dawn is a computer genius, and she helped me using her alien knowledge. Okay, so an irrational number is a number that you can't write as a ratio, aka a fraction. So 2 is a rational number because you can write it as 2 over 1 or 4 over 2 or something like that. 3.5 is a rational number because this already is in fraction form, right? It's like 3 and 1/2. Even numbers like even numbers like 33.3333 and then the 3 repeats forever, that's also a rational number because you can write it as 1/3. So, so all of these things are rational numbers, but it's confusing me because I have written irrational number here and then I wrote a bunch of rational numbers. But, oh, can I make this bigger? No. Okay, so, I don't know how to use this. Okay, here we
A
go.
whiteboard?
You had no idea it had anything to do with ratios, fractions, you just learned it in terms of square roots. Well, yeah, so I'm about to get to that. So an irrational number, it has a lot to do with square roots because many square roots are irrational. So all of the square roots that are not perfect squares are irrational. All of the cube roots that are not perfect cubes are irrational. And by that, I mean the square root of 64 is a perfect square because you can say 8 times 8 is 64. So the square root of 64 is 8. And that's just a cool whole number, right? Good. The square root of 25 is a perfect square. It's 5 times 5. 25, right? So square root of 25 is 5. So whole numbers.
I'm paying attention. I'm taking it in.
So these are our whole numbers. But if we have the square root of 3, that's something different entirely. Fiyera, do you have a calculator real quick?
Yeah, I was just going to bring mine up.
Yeah, so can you do the square root of 3 on your calculator?
1.7320508076.
Right, so your calculator shows that much, but it's actually going to be a never-ending decimal that never ever repeats, and we cannot call this a rational number because we cannot write this as a ratio at all. This doesn't exist as a ratio, but it does exist as an irrational number. So square roots that are not perfect squares are always irrational numbers, and we're actually going to get back to that. That's the main
Oh my god, I'm
focus.
sorry. I can't believe you're not paying attention to the chat.
No, I see that she said P instead of pi.
Okay. I'm losing it over here over that.
I was just ignoring it. But
you're a good teacher.
Okay, so does that make sense?
Yeah.
Okay, so we can't write that as a ratio, so it's an irrational number. Yeah, so as I was saying, which is, I can do one on imaginary numbers, Veronica. It would probably be a lot shorter. So as I was saying, that's kind of where we're gonna end up, the square root of something, because that's going to be very important to us. Right now, so I'd like to go over a couple of... Hello, yes? Do you have a question, user? Benny has a question. Okay. Why do we know this as humans? Okay, actually, that's the main focus of our lesson. That is the main focus. So you will learn how we know this as humans.
Oh, so, why? Why do we know? Why would we ever need the square root of 3 for something?
Square root of 3 is not as important as the number that we're going to look at, which is the square root of 2. And I'll show you why that's important. But first, I want to show you some famous irrational numbers. So, Yuzu was right. One of the famous irrational numbers is pi. And do you know what pi is?
3.14 something.
Yeah, 3.1415.
Not 69.
Yeah, right?
Helps with circles.
Okay. Yes, exactly. So what does it have to do with circles? Do you know?
Pi times the radius is the area.
That's
Right?
true. Yeah. 2 pi r is
2 pi r.
is the circumference.
I don't remember anything.
Yeah, and pi r squared is the radius.
Okay.
I mean, sorry, not radius. Area is what I meant to say.
Area.
But pi is the ratio of the circle's diameter to its circumference.
Oh.
Yeah, so every circle has this ratio. Why they call it a ratio when this is an irrational number? That's anyone's guess.
Well.
But you're going to get into another ratio that's an irrational number. It's called the golden ratio. Anybody heard of the golden ratio?
That spinny thing in art.
Yes. That is the golden ratio. Do you know what else it shows up in? Yes, I am the first VTuber to teach math to the devil. I can guarantee you that. Math, yes, it shows up in math. So it's, have you heard of the Fibonacci sequence?
Yes.
Yeah, that's exactly right, Veronica. You can keep making smaller rectangles of the same dimension. So the Fibonacci sequence is a sequence where it starts with 0, actually, not 1. It starts with 0, and then you add these two numbers and you get the next number. So 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, and it'll go on. And it shows up in nature a whole lot. A lot of flowers, actually, maybe all flowers. I think most flowers use the Fibonacci sequence because it's very, it's helpful for them to, plant seeds in a certain way, I guess, or spread pollen, something like that. I'll probably do an entire video on the golden ratio and the Fibonacci sequence.
So you're telling me that plants know math? Plants
know math, yeah. Actually, I think plants probably knew math before humans knew math. So, yeah, so I'll probably do an entire video on golden ratio and Fibonacci because it's super interesting. But, okay, what's the next one? E. Anybody know what E is?
E. A letter.
It is a letter, but it's also a number.
Like I, right?
2 point something. I don't actually know what the value of E is. Yeah, but you're right. E is a number like I is a number. So, yeah. E is Euler's number.
2.71828182885. And then it probably goes on, right?
It does go on. It goes on forever because that's what irrational numbers do without ever repeating. So, E MC squared, you know what? E equals MC squared is something completely different.
What?
That's not Euler's number. That's a variable that Einstein made up to stand for something else.
It's a different E?
It's a different E, yes.
That's not confusing at all.
Yeah. At least I think it's a different E. Holy shit. I don't know too much about E.
Well, okay. I'm looking it up.
Yeah, please look it up, because I would like to know.
E equals MC squared.
I think it is energy. Number? Energy equals mass times something something, right?
Yeah, I don't think it's the same E.
Yeah, I don't think it is either.
When I started typing it, the first thing that came up was something about elves.
Oh! I don't think so. Hey, not that kind of E. Okay. Oh, and I forgot to put down that the golden ratio is also represented by phi, which looks like this. So if you ever see this, it's talking about the golden ratio.
B5 from.
Exactly. I declare thumb war.
E is energy.
M is mass. C is the speed of light. Okay. Cool. So yeah, energy, that's not the same as Euler's number. So those are some famous irrational numbers. But not the irrational number we're going to talk about today. The irrational number that we're going to talk about today is square root of 2. The square root of 2. A very important irrational number. And this is the irrational number that kicked it off. This is how people found out that there were even irrational numbers. Because before that, we didn't know that there were irrational numbers. We thought that numbers could only be ratios. And during this is like in ancient Greek times. So there was a Greek guy in the basically cult of Pythagoras. And do you guys know what Pythagoras did?
He created the Pythagorean Theorem.
Yes, very good. Do you know what that is?
No.
Anybody know what the Pythagorean Theorem is?
I feel like I know it in the back of my mind, and when you tell me, I'll be like, oh yeah.
Triangle, yes, it has a lot to do with triangles. A squared plus b squared equals c squared. Good, yes. So in a right triangle, the squares of both their sides equals the square of the hypotenuse. Which is important to what we're about to do also. So Pythagoras had a cult of mathematicians or just philosophers or people or whatever. And these guys all thought that every single thing, not just numbers, but every single thing could be represented in a ratio. They were like, oh, music is a ratio, plants are a ratio, spirituality is a ratio, whatever. So they thought everything could be represented as a fraction or a ratio. And then this guy Hippasus, I think his name is. He was part of this cult, and he was like, okay, but I'm gonna fuck around with squares and shit, because my guy Pythagoras told me, let's see, if I have a square like this, and pretend this is a perfect square, and I draw a diagonal, what does this create?
Square, oh, sorry, triangles.
That's right, 2 right triangles, right? And so, according to Pythagoras, a squared plus b squared must equal c squared, right? But what if we have a right triangle, or a square, with sides of length 1? Then what happens? Well, since a squared plus b squared equals c squared, what's a squared going to be? This is a, and this is b.
Huh? Are you asking me?
I am. Or the chat. Whoever
I
wants
was
to
reading
answer.
chat. What was the question?
What's a squared going to be?
What, just 1?
Yeah. So 1 squared was just 1, right?
Yeah.
And then b squared is going to be the same. So 1
Yep.
plus 1 equals c squared. Okay. So 1 plus 1 is what?
2.
2. Which means that c squared equals 2. Now let's remember algebra. So how do we get rid of an exponent like this?
You'd have to do the square root of 2. You have
That's
to
right.
move it over to the other side.
That's right. We have to square each side, or square root of each side, right? That cancels out our exponent. So we end up with c over here. and the square root of 2 on this side. And so then Hippasus was like, what the hell? C is the square root of 2? What does that mean? Square root of 2. I've never seen this weird number before. Okay. So, then let's go back a minute.
Let's
let's hold right here and remember this triangle that has sides of 1 and a hypotenuse that is the square root of 2, okay? Why is the Pythagorean theorem even relevant, true? How do we know that it's true? Well, it comes back to squares. So, alright, so imagine, let's look at a coordinate plane. Because we can't do this proof of square root of 2 being irrational without relying on the fact that the Pythagorean theorem is is true, right? So in this case, let's figure out why it's true. So look at this coordinate plane. You remember these coordinate planes?
Yes.
Okay. So, if we graph 4 times 4, which is just 4 squared, right? So 1, 2, 3, 4 over here, and then 1, 2, 3, 4 over here, and we connect these lines, and it becomes a... What does it become?
Square.
Square. It becomes a square. So, this is a square with area 16.
Why are you booing?
I want to know, yeah, why are you booing?
Why are you booing?
Why are you booing at the square? You don't like squares?
Oh, like 4 times 4?
Okay, and then, so when you take a square root of a number, you're saying, if I have a square with area x, this case 16, what identical number do I have to multiply by itself to get there? What is the length?
Scared of flying.
I'm booing the plane. Got it. Oh, so what number does it need to be multiplied twice? And we already know that's 4, right? So, that's why we call it squared.
What?
That's why we call it
You know
squared.
what? That's crazy. I never thought about that.
Yes. So, that's why it's 4 squared, yeah. Because it actually makes a square. So that's important, but...
Wow, I'm learning so much.
Okay.
I have a question about history and math.
Yes.
Is this one of those things that the Egyptians realized first, but like the Greeks get all the credit for it, or is it something that they did not and genuinely came from Greece?
I believe that this one actually comes from Greece.
Okay.
I know there are a lot of things that were discovered by like people in the Fertile Crescent or India that, just like you're saying, were discovered first, and then either people in the Western world discovered it concurrently or after, and they just didn't have much interaction, so they couldn't have known. And then, consequently, as people who live in the Western world were like, oh, yeah, they did that thing. And not even realizing that the other people did. But I think that this is genuinely something that Hippasus found.
Okay.
Yeah. Okay. So.
I like that you gave me the history of it too. That's interesting.
Yeah. Thank you. I am smarty pants. Okay. So again, let's go back to our triangle and explore the Pythagorean theorem a little bit. So here we have a right triangle. Sexy. All right.
Okay.
So let's draw a square here.
Not what I would say.
This is a rectangle, but pretend it's a square. Pretend that all of these are squares. Okay?
This is a rectangle. Okay, I see.
Okay, and this is a... No, Lucky, no. Oh, God. Can you guys... Are we still here?
I'm here.
Okay, my kitty cat has walked across the keyboard and I get scared. Okay. So A, side B, side C, just like normal, right? So if A squared plus B squared equals C squared, and we see how this is A squared, right? Because going back to our coordinate plane, this square must have side lengths of A, right? And the area is A times A, which is A squared.
Can I just interrupt for a second?
Of course.
Do you want to hear something crazy?
Yeah.
So I was looking up what Hippasus on Wikipedia, and here's what it says in the little blurb on the top of his Wikipedia page.
I have a feeling I know what you're going to say.
The discovery of irrational numbers is said to have been shocking to Pythagoreans, and Hippasus is supposed to have drowned at sea, apparently as a punishment from the gods for divulging this.
Yes.
That's insane.
Yes. They hated the idea that there was a number that could not be written as a ratio so much because, like I said, they were really obsessed with ratios and thought that it existed like everywhere. And they were like, this explains the whole universe. So they were like, you're wrong! That can't be true! And then killed him.
Wow. Even the gods were like, no, we're not with this.
Okay, so.
Right, back to the math.
Yeah, so back to this square. These squares, rather. So, since this is a straight side of A and all of these, since it's a square, the side lengths are all equal, right? So this must, the area must be A squared here. A squared. And the area must be C squared here for the same logic, B squared. So that's one way to think of the Pythagorean theorem, right? So there's that. And okay, so here's another way to think about it. We have a square like this. That's, oh my gosh, that's not right. Okay. A square like this, like on a fun little angle here. And if we, oh, wait, hold on. I'm going to draw this other one first. That would be better. So we have a smaller square over here with side length A. So all of these are A. And if we draw a diagonal, we say that's C. Then we can draw a square that has side length C. And so basically it says A squared plus A squared equals C squared. Because here is C and she is squared. Here is A and she is squared. So 2A squared equals C squared, which is just basically the same thing as saying A squared plus B squared equals C squared.
Okay. Sure.
One more way to think of it is that if you take this is my favorite way because it's very visual. So if we take, let's draw a square first because that's probably easier. If we take 4 identical right triangles and form them like this, then the area of this inner square Any thoughts? Since just knowing what we know about right triangles, we have B here, side B here, side A here, side C.
C squared.
Yeah, it would be C squared. Okay, so let's keep that in mind. And then we can rearrange these triangles. We can put we could put 2 here. And we can put 2 here and imagine those are equal. And these are the same identical right triangles as before, right? So if we rearrange them, then this is side B, and this is side B, and this is side A, and this is side A. So this is B squared, and this is C squared, right? This square.
Hold on, it's catching up. Yeah, sure.
This square has area B squared. This square has area C. Sorry, A squared, not C squared. A squared.
Yeah, wouldn't it be A squared,
yes.
not C?
Yeah. So, since we didn't change any sizes here, right? These 4 triangles are the same size as these 4 triangles, and we arrange them just in different ways, the empty space must be equal. Does that make sense? We have A squared plus B squared here, which is the same as this because it must be the same amount of space, right?
Mm-hmm.
Does it make sense?
Yeah.
Okay. Chat, what do you think? Does that make sense?
Ba 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 ba. C.
Ba 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 ba. C.
I think so. Yeah.
Yeah. So that's my favorite way to prove the Pythagorean theorem. So now that we know that's true, we can go on to proving root 2 is irrational. Because we don't just blindly believe Pythagoras. We have to see that it's true. Okay. There was one more way I wrote down, but I think that's the best way. So let's go back to our funny little square here with side lengths of 1. And we said that the hypotenuse was square root of 2, right?
Yeah.
Okay. So we can estimate this guy. And what does your calculator say it is?
1 second. Square root of 2?
Mm-hmm.
1.414213562
So, yes. So again, that's all your calculator shows, but it's an irrational number, so it will go on forever and never repeat. So, the square root of 2 is irrational, right?
Yeah.
But we don't blindly trust Hippasus. We need to figure out that it's true. So, there are a couple things we need to know before we start with the proof. And that is, first thing, is that... What the fuck?
Oh, what the fuck?
The first thing...
Excuse my language.
Is that an even number times an even number. So, let's say that even numbers are defined as 2 times some number, some integer. Which makes sense, right? Because we have an even number 6, which is 2 times 3. And we have an even number 42, which is 2 times what now?
What? 42 is 2 times, hold on, 21.
21, good job, guys, yes. So, an even number can basically be reduced to 2 times some number, always. Even just 2 is 2 times 1, right?
That's true.
So, we have all those, we know that that's what an even number is. That means that an odd number can be represented as 2n plus what?
1.
1. Exactly. Every odd number is 1 more than an even number, right?
That's crazy.
Okay, so we have that. Oh, and we need to remember also that 0 is even here. Even 0 is divisible by 2, so we're good.
Drop something. Hold on.
Okay.
Okay, I'm back.
Yep, n is 0. Good. So 2 times 0 plus 1, 0 plus 1 is 1, and that is an odd number.
What about negatives?
Negatives, same thing.
Okay.
Same thing. Because if we have 2 times, let's say negative 4, that's going to be negative 8. So this is divisible by 2 also. So it's still an even number.
Cool.
Yeah. Okay. And, okay, so even 2n, odd 2n plus 1. And obviously the n can be whatever you want. Yes, exactly, Yuzu. If it's plus 1, then that's just negative 7, which is an odd number. Excellent. Okay. So now that we know this, we should remember that if you multiply an even number times an even number, you always get what kind of number? Do you know?
Even.
You always get an even number. Can we come up with an example?
2 times 2.
2 times 2. That's a perfectly good example. Even times even gives us 4, another even number. Okay. In fact, any number, even or odd, any number, even or odd, multiplied by an even number gives us what?
Even.
An even number. So we could say 2 times 3. That gives us an even number 6, right?
Ah, totally.
So any number times an even number equals an even number, and the only way you can get an odd number... Sorry, Matt.
It's because it's filled with so much info.
The only way you can get an odd number is by multiplying 2 odd numbers together. Odd times odd equals odd. So in this case, we can think about 3 times 3. That equals 9. Right?
Yep.
All this to say, let's go back to our even numbers, that since an even times an even equals an even number, it follows that if you were to square an even number, what kind of number would you get?
Even.
Yeah, exactly, because we're multiplying 2 even numbers together, so by definition, this number must be even. Okay, so when a is even, a squared will be what? What parity?
Huh?
Will it be even or odd?
Even.
Even. So that is extremely, extremely important here in this proof. Good job, everybody! You all got it right!
Whoa!
Okay. Alright, so the last thing we need to remember... Actually, let me write... I'll write them when we're done. Okay. The last thing we need to remember is that a ratio or rational number can always be reduced to lowest terms. Do you remember what that means?
Yep. It's like if you have 8 over 4, you can reduce it to 4 over 2 or 2 over 1.
That's right. That's right. They have a factor in common, and that is... Well, they have 2 in common, but Their greater factor is 4, right? So it reduces to 2 over 1. Exactly, that's 2. And this is lowest terms because these two things are called coprime. Do you know what coprime means?
Nope.
Coprime means that they have no factors in common.
Okay.
Yeah.
Makes sense.
Okay. So when they're in lowest terms, we say that each of those numbers are coprime. And yes, Benny, I said parity. So parity like this, which just means the state of being either even or odd.
What? Oh, parity like that.
Yeah, so we can say that when we count, we alternate parity.
Not parody like Amish paradise.
No. Although I do prefer that.
I didn't know that either. I didn't know that was a thing.
Okay, so our two important things to remember now are that if you square an even number, then you get an even number. And the second thing is that we can reduce any fraction to lowest terms. Okay?
Mm-hmm.
All right. And if you're not, so a very important thing to remember also is that you cannot reduce a ratio of integers to lowest terms, then it is not a ratio of integers at all. So
okay,
that's how we're going to prove that square root of 2 is irrational. So let's do a proof by contradiction. Do you know what that is?
No.
Users asking what is it if it's not a ratio of integers? It's an irrational number.
Yeah, stupid. I'm just kidding.
So, sorry, did you answer for proof of contradiction?
I said I don't know.
Okay. Anybody in the chat know what a proof of contradiction is? Proof by contradiction, rather.
You're gonna have to wait for the delay.
Yep, exactly. A proof by contradiction.
Ooh, smarty pants.
Is when you prove something by showing that the opposite cannot be true. Okay. Oh, excuse me. Uh-oh, Benny's refreshing.
You good?
We good?
You good?
Me? I'm good. Okay. So let's assume that root 2 is some ratio of integers. We'll say it's not irrational. We'll say that we're trying to prove that it's rational. Right? So we're saying that root 2 is some ratio of integers p, q, so p and q are both integers. So, and now we're also assuming that PQ is in its simplest form. Simplest form, because we can always reduce a ratio to lowest terms, right? So simplest form. So let's just assume that PQ is already there. It's in its simplest form. That means that P and Q are coprime, so they cannot have, what does coprime mean again?
Same factors or something like that.
Yes,
they don't share factors.
That's right. They don't share factors. They cannot have factors in common. Okay. So that's
what does it mean when... So, I don't know if this is related, but there's a Christmas song I know where it goes, something something your P's and Q's. What does that mean?
I think that comes from mind your P's and Q's. That's a phrase, right?
Yeah,
I
but
think
what
that
does it
just means
mean?
like have good manners, right?
Okay. I don't know.
Doesn't that have to
That's
do
what I'm
with
asking.
writing in cursive? I don't think it has to do with writing in cursive, or maybe it does. I don't know. You have to draw them real good, because that's polite, being a polite little child.
Oh. Okay, so it doesn't have to do with P and Q ratios.
No. Well,
Okay.
I mean, we could honestly pick any letters we wanted for P and Q here.
Yeah, I am sure you can, except for E.
We could pick E. We could.
Oh, someone linking a Wikipedia article.
Because P and Q are opposite loops. Okay. Yeah, that makes sense. I've never been particularly good at cursive.
I'm pretty good at cursive.
Yeah?
Yeah.
Nice.
Yeah, people usually can't read my handwriting because I'm good at it.
Oh. Wait, what? You're like people writing in Russian cursive or something?
I write in like semi-cursive.
Okay, so do I usually. Like when I'm taking notes or something, I do.
Yeah.
Okay. Yeah, like everything's connected.
Yeah, exactly.
Okay, so we're assuming that these guys are coprime. That's the main thing that we need to remember. So I'll erase all this crap and... So P and Q are coprime.
I have a new invention idea.
Okay.
How do I say this? Smelly chalk that smells. It's not flavored chalk, but like chalk that like smells like strawberries or like apples or something.
You mean like Mr. Sketch, but for chalk?
Yeah.
I think they have that.
What?
Yeah.
I can't believe this.
And if they don't, then I'm just then I will say that's a great idea and they should have that.
Okay. Yeah, scented chalk, exactly.
Scented chalk, not flavored chalk.
Flavored chalk would be, that's just Smarties, but
Smarties.
I like Smarties. That's coming from someone who likes Smarties.
I don't. I really don't.
I love Smarties. I could eat like 10 of them at once. Scented chalk. I can't believe it's real. Yeah. They stole my idea.
And it's non-toxic, so you can eat it.
Oh. I mean, that doesn't mean you should. Dissatisfied does not have any scent for being scented chalk. One review, that's 1 star.
Wow. And it's prevented anyone from ever buying it ever again.
Mm-hmm.
I would say that I would rather eat a Smartie than a lot of things.
I would think that you would like Smarties, considering you're one yourself.
I think that the other candy that tastes like chalk is way worse than Smarties.
Which one?
The conversation hearts.
Oh yeah, those are nasty.
They're gross.
Those are not to eat.
No. They're just to look at. You pick one out of the thing, and it's like...
What happened? Why are you cursing?
Kiss me!
No, candy hearts are nice. They're a nice sentiment, but they're not good. Okay, well, you're evil, so moving on. You're literally an alien. Of course, you don't like that, or you like weird human food.
Kiss me!
Are you Furby now?
No, I'm being a conversation heart. Fax me!
You sound like a Furby.
Telegram me! I sound like a Furby? What if Furby said kiss me? Kiss me!
I would. Well, kiss would I? I don't think I would kiss a Furby.
Fiyera, please! I'm speaking directly to you! Please kiss me!
I would take the batteries out.
Please! I need your touch!
Ooh. Let's get back to math.
Okay. Let's get back to math.
Back to math.
Okay, so if we assume that P and Q are coprime, that P over Q is in its simplest form. So we're asking ourselves now, can P over Q exist? Can it exist?
I mean, you just wrote it.
That's true. Let's figure it out. So we take this, our equation, and we'll multiply both sides by Q. Do you know what we'll get if we multiply both sides by Q?
PQ over Q. QP. What?
QP?
What am I saying?
Cupido?
What was the question? I'm sorry, I'm in Furby brain right now.
That's okay. We're asking ourselves, let's multiply both sides by Q. What do we get? What do we get on the left side?
Square root of 2Q.
That's right.
And then, oh geez, PQ over Q?
Well, we could do that. We could say PQ over Q, but then we can just cancel these Q's, right?
Oh yeah.
Yeah. So since multiplication and division are inverse operations, exactly, we just get P. Yeah. And, okay, so the square root of 2 times Q equals P. Now, let's get rid of that pesky radical. Let's get rid of the square root. How do we get rid of the square root?
You square.
Yeah.
P squared.
Yeah, P squared, and then if we square this, then we get rid of the square root, right? So we have now QQ squared.
P actually stands for piss, just so everyone knows.
P stands for piss? What does Q stand for?
Quiz.
Quiz.
No? I don't know. Yeah, quiz.
Quiz?
Quiz.
Quiz, like this?
Quiss. It does not stand for that.
I feel like that's a swear. Quiz.
Quiz? Quiz is, I think Quiz, there's a cereal that's called like Quiz.
What?
Yeah, it's like an old alien
Quiz
cereal.
Quizpa?
About
or quiz?
Quiz. Let me look it up. I honestly don't know. It's something that I've heard but never.
Don't worry. Don't worry. I've already read the chat and I'm choosing to ignore
Quisp.
it. Quisp.
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 With a P.
What is it?
It's cereal. It's an alien cereal.
What does that mean? Alien cereal?
It's a cereal with an alien as the mascot. It's just corn cereal.
Corn cereal. So it's like Life or corn checks or something?
Life is not cereal. Life is life.
Life is cereal. What are you talking about? Of course life is cereal.
Anyways, no, life is... you're telling me your life is a cereal?
You don't know what life is? Hey, Mikey, he likes it.
I'm trying to make a joke.
Oh my god. I thought you were being serious, Pete.
Oh my god.
Life is a cereal and a game.
I want to eat it all night long.
Okay. Now, what do we notice about these guys?
1 second.
My little thing says first time chat from viewer, and it's just you, Fee.
Why aren't you clicking the link? Anyways,
Oreo O's are the same. You're just weird. They taste exactly the same as they used to taste. And I know, because I used to eat them every single day.
Oh, a death threat!
Uh-oh, I'm gonna ban you. Then you'll never know. Then you'll never know if square root of 2 is irrational.
Well, you told us at the beginning.
Huh?
Okay, what was the question?
So now, what do we notice here? What's special about 2q squared equals p squared? Kind of relating it to the rules that we established at the beginning. Do we see anything that looks kind of like anything in rule number 1? That's right, Yuzu Kuro. It's
no,
even.
I said it first, actually.
That's right, Fee. That's right, Benny. All of you are right. 2q squared is in the 2n format, where n is some integer, while q2 has already been established to be an integer. Since q is an integer, q2 must be an integer. Q squared, rather. Q squared must be an integer. So 2 times this integer equals something. This is something evil. Evil, no. Even.
Something evil? Is that what you just said?
That is what I just said, but that's not what I meant to say. Which means, what does that mean about PQ? What does that mean about P squared?
It's evil too.
Yep, it's also evil. So these two are even. These two are even. Great. And since these two are even, what can we infer about P? Just regular old P.
Even.
P is even. Okay, well, now we're getting somewhere. So let's add another thing that we know is true here. So we know, number 3, that P is even. Okay, great. So let's go back to our equation now. We have 2q squared equals p squared. Since we know that p is even, we can write it as 2 times some integer, right?
Mm-hmm.
So let's write it like this. Let's write p as 2a. No, this is going to be p because p is even, so it's 2 times some integer, and the integer here is a. Right?
What about the square?
That's right. Yeah, we're about to do that next. There you go.
Okay.
So, we can simplify now, multiplying 2a by itself, right? True a, because that's what 2a squared is. So, if we multiply these together, what do we get?
4a squared.
Yeah.
Yeah.
Yeah. And now we can divide these both by 2. So now we get q squared, 4 divided by 2 is 2. So we have 2a squared. So q squared is the same as 2a squared. Okay, now what do we notice?
Even.
It's even, right?
Are we just gonna do this over and over and over again?
This is the last time.
Okay.
So, why is it even?
Because the 2?
Yeah, 2 times a squared. A squared must be an integer, so 2 times some integer, that's even, which means that q squared is even, which means that q is...
Even.
Okay, but now, do we see a problem with our original ratio? We said that this was in lowest terms, but why can it not be in lowest terms?
I don't know.
Okay. Well, if p is even, we can write that as maybe 2...
P and Q are even, they can't be 1.
P and Q are even, they can't be 1. Can you elaborate?
I'm pretty sure every math teacher does take a shot.
I don't drink.
Well, not you. You're an overall teacher.
That's true.
1, whatever the square root is.
1 point, whatever the square root is. Okay. We're getting there. So, we know that p is even. How can we rewrite p to be in the format that we've been talking about?
You just erased it.
2n. 2n. Good. So p is 2 times a, maybe, right?
Yeah, it was a.
And then how do we write q?
Q squared, was it?
No, it's the same thing. Q is also even, right? So how can we write that? How can we rewrite that?
2n,
right? Yeah. 2b.
2n,
2b
yeah.
is a good one, yeah.
2b or not 2b.
So we know that p is 2 times some integer, because if p is 4, then it's 2 times 2, and if q is 6, then it's 2 times 3, right? So this is the same thing. That's exactly what we're writing here.
Your head's in the way again.
Oh, gosh.
You gotta stop writing on that side.
I know. Okay. Well, we don't need this anyway. But now what's the problem?
It's not in its lowest term.
Yeah, why is it not?
Because if it was, then it would be 1a over 1b, but it's 2a over 2b. They both share a common factor.
They both share a common factor of 2. Because, that's right, well, we can't cross out the 2 because we know that these are both even numbers, right? You're right. If we did this, you're right. If we did this and canceled the 2's, then we would have a over b. But, because we already assumed that p over q is in lowest terms, and now we have proved that it's not, p over q can't exist. Because we know that p must be an even number, and q must be an even number. So we can't just cancel out the 2's because we already have the p over q here, right?
Mm-hmm.
It's as if we said, okay, the square root of 2 is the same thing as 12 over 24. And this is in lowest terms. And that's it. It must be in lowest terms. Well, that can't be true, right? Because these have common factors. At least one common factor of 2. So, impossible. This guy is a fraud. He doesn't exist, and that means that the square root of 2 is irrational. Because there's no ratio that can represent it.
Okay. That makes sense.
Yeah. So that's the proof I know. There might be other proofs, but let's see. So what have we found? P and Q cannot be coprime. Our ratio can never be in lowest terms, and so this ratio does not exist. It does not, well, at least to humans, it does not exist. In human math, it doesn't exist, but maybe
What
in
do
like
you mean by that?
maybe in some far-flung planet they know how to rationalize this. But not me.
Okay.
Okay, now, just one more quick aside. So there are number systems. Rational numbers are one of them, and inside that is integers. And integers are positive and negative whole numbers, basically. And we already remember what rational numbers are, right?
Yeah.
And then irrational numbers are things like the square root of 2 and pi. And just as an extra, 2 pi, that's also going to be irrational, right? Any multiple of pi, since this is an irrational number, is also going to be irrational. So any or if we did like 3e or something, that's also going to be irrational. So, rational or irrational? Pi over pi. What do we think?
Irrational.
Irrational, okay. Anybody else?
Oh, you make it sound like I got it wrong.
I just want to see why we think it's irrational or rational.
Rational says Yuzu Grove.
Yuzu says rational. Okay. Anyone else want to guess?
Well, yeah, it would just be 1.
You're right. You're absolutely right. This would just be 1 because anything divided by itself is 1. So pi over pi is rational.
Well, sometimes, personally, I think the number 1 is kind of irrational at times, so...
1 is the loneliest number. Please do a stream sometime. Actually, I have all my notes written out for a stream explaining why we can't divide by 0, and I would do it right now if you want me to.
Let's have more people on that one. I feel like just having me... We need more people being like, why?
Okay. Alright, guys. Well, that's the end of my stream then.
Oh, that was it? Okay.
Does anybody...
Can you draw something on the board?
Yeah.
Draw Furby.
Draw Furby, okay.
I like that you're like leaning out of the way.
Alright. Draw a candy. Okay.
I love that Furby. It's going, kiss me!
Kiss me! You're right, it needs ears.
That's like a penguin Furby. It has holes.
It has holes?
I love it. Draw a heart. What kind? Real? Oh. Draw Kirby.
Draw Kirby.
Just a circle with a face on it.
First you make a circle, then you dot the eyes.
Oh, perfect Kirby. Cute.
Okay, I have one more thing before we disband here.
Giveaway.
It's a joke. It's a math joke that someone told me. Okay.
7, 8, 9.
Well, it starts with that.
Oh.
So you know how 7, 8, 9?
Yeah.
That was pretty sad, right? But do you know why he did it? Do you know why 7 did it?
He was hungry.
He was hungry, yeah. He was just trying to take care of himself. He heard that you're supposed to have 3 square meals a day.
Oh boy, that's a good one.
Okay, I'll try to have a better math joke next time. I like the smiley face. One of my good friends taught me that joke. Okay. Alrighty. Goodbye, everyone.
Goodbye, everyone.
Thank you for joining me, Fee.
Thank you for teaching me, Mickey.
Bye.
Maybe I'll actually remember all this.
Maybe you will. I'll quiz you next time.
Oh, how about you don't?
Okay. Bye. Wait, my signature sign off. Sparkle and shine. Bye.
See you guys in hell.